In this video, we are going to derive all three of the double angle of cosine identities. We're going to start like we did with the double angle of sine, where we used the sum of sine, or the sine of a sum. Now we're going to do the cosine of a sum. So if we're saying that we have if we're having the cosine of 2u, well, that means we're going to have the cosine of u plus u. So that means that we have the cosine u minus sine u sine u. Well, that ends up meaning that the cosine of 2u is going to be cosine squared u minus the sine squared of u. And that is going to be what our formula is. Cosine of 2u equals cosine squared u minus sine squared of u. Now let's use the other equations that we have here to derive the second one. So we just used this one. We just found that the cosine of 2u was cosine squared of u minus the sine squared of u. So we're going to take that and we're going to keep cosine in it, but we're going to substitute out. So since we know that the sine equals 1 minus cosine squared minus 1 minus cosine squared of u. So that means we're going to have cosine squared minus 1 plus cosine squared u. And that means that our cosine of 2u equals 2 cosine squared of u minus 1. And that ends up being the formula that we have down here. And then we're going to do that one more time, where now we find the third. We're going to find the third one. So one more time we'll do the cosine of 2u equals the cosine squared of u minus the sine squared of u. And this time we're going to substitute out the cosine squared of u, which is 1 minus sine squared u. And we're going to subtract sine squared u. And so we get the cosine of 2u is 1 minus 2 times this sine squared of u. Fantastic. So now we have all three plus the double angle of sine. And we'll do a quick summary now, where the double angle identities, the sine of 2u is 2 times sine u cosine u. And then we have the cosine of 2u will be cosine squared minus sine squared. We could also write it as 2 cosine squared minus 1. And lastly, 1 minus 2 times this sine squared of u.